Now, on section 2 of this course, we focus on network concepts, specifically network fundamentals. So before we touch routers, switches, IP addresses, or security, we must first understand what network actually is and why it exists. Many people, they try to jump straight into configuration, without really understanding the fundamental, and that's when networking becomes confusing. So in this section, we slow down on purpose, and then we build understanding first, because strong fundamentals just make everything else in networking logical and predictable. So think of this section as a foundation of a building. If the foundation is weak, then the entire structure will, eventually collapse, or it will fail. Now, what is computer network? So let's start with the most important question. What is a computer network? Computer network is made up of two or more devices that are connected together so that they can share data, they can share resources and services. So these devices do not just send data randomly, they communicate using agreed rules known as protocols. Right? So without protocols, devices could send information, but the receiving device would not know how to interpret that information. So imagine that you get a letter written in Mandarin. So to you, that letter is going to be useless, right? So every time you load a website, send an email, you stream a video, you connect to Wi-Fi, your device is participating in a network communication process. Right? Networking is not about cables. It's not just about cables and hardware alone. It's about communication, coordination, and control. So why does network exist? Now let's talk about why network exists in the first place. Imagine every computing organization working completely alone. So each device will need its own printer, its own internet connection, its own copy of every file, and its own security rules. So that will be expensive. Right now, we sitting here, and then we've got computers connected to the internet. So imagine, or all of you have got phones, right? Imagine that you bring your own router, or I provide you a router to connect to the internet, give you a router, and one for myself as well. I mean, that will be extremely expensive. But right now, we're all connected to Wi-Fi, right? So network exists to solve these problems. They allow resources like files, printers, applications, and internet access to be shared. Right now, we're sharing internet access. So they allow centralized management where administrators can control users, permissions, updates, and security from one place. So they enable communications and collaboration as well, which is essential in modern businesses. So finally, network allows organizations to scale, right, to grow without rebuilding everything from scratch. Now let's look at the devices that participate in the network, starting with the end devices, also known as hosts. Now, end devices are devices that create, that send, that receive, and consume data. Examples include laptops, desktop computers, servers, smartphones, network printers, IoT devices as well. So when you send an email, for example, your laptop is an end device. So when you access a website, the web server is also an end device. So in troubleshooting, identifying the end device is often the first step. A technician must always ask, is there a problem starting at the user's device? Or is it happening somewhere else in the network? Now, next we have intermediary network devices. Now, these devices do not create data themselves, but instead they manage how data moves through the network. Switches connect devices within the local network. Routers connect different networks together. Firewalls enforce security rules by allowing or blocking traffic. Wireless access point allow devices to connect without cables. So think of an intermediary devices like traffic controllers. They decide where the data goes and how fast it moves, and whether it is allowed to pass at all or not. Now, a network resource is anything that can be shared on the network. So this includes file servers, application servers, printers, storage systems, databases, internet connections, and cloud services. Most modern networks operate using client-server model. Right? So in this model, a client requests a service, and then the server provides the service. So understanding where the resource is located and how it is accessed and is important for both performance and troubleshooting as well. Now let's briefly compare client-server and peer-to-peer networking. So in the client-server networking, control is centralized. Right? Servers handle authentication, data and storage and services. So this model is scalable, it's more secure, and it's manageable, which is why it is used in enterprises. And then peer-to-peer networks allows devices to share resources directly with each other. All right. Peer-to-peer is simple and it's inexpensive, but it doesn't scale too well, and it lacks strong security controls as well. So as a technician, you will mostly work with the client-server environment. Now, network geography describes the size and the physical reach of a network. A personal area network, or a PAN, covers a very small area, such as a Bluetooth devices, USB, so that will fall under the PAN, or personal area network. And then a local area network covers home, office, or a building. Like here, we actually connected using a local area network. There is also a wireless local area network, and then there is which uses Wi-Fi instead of cables. Then we have a metropolitan area network that connects multiple LANs across the city. Then a wide area network connects networks across countries and continents. The internet itself is the largest WAN in existence. Okay, the internet is a network as well. Now, network geography matters because size affects everything. Larger networks introduce more latency, higher costs, greater security risks, and increased complexity. A network designed for a home will fail if it's used for enterprise. Right? So as the network grows, technicians must change how they design, how they secure, and how they manage them. So understanding geography helps you to choose the right technologies for the job. Now, a network topology describes how devices are connected. So the most common wired topology today is a star topology. I think I went ahead. It's a star topology where devices connect to a central switch. A star topology is easy to manage and is easy to troubleshoot. And then mesh topology provides multiple paths between devices, and it offers high redundancy as well. And then bus and ring topologies are mostly legacy designs, so meaning they are old, right? But understanding them helps to explain modern concept. Topology can be physical, how cables are laid out, or logical, how data flows. Then wireless network replaces cables with radio signals rather. So most wireless networks operate in an infrastructure mode, right, where devices connect through access points. Now, wireless introduces challenges like interference, signal loss, and security threats. Now, good wireless designs focuses on coverage, capacity, and protection as well. It must be planned rather, not guessed. You don't just decide I'm gonna put a access point there in the corner. No, you plan it. But we'll talk about that when we actually get into those topics. Now, and then data centers are designed differently. from office networks. So they require higher speed, low latency, redundancy, and scalability as well. And in traditional data centers, they use three-tier design: core, distribution, and access. Modern data centers often use spine and leaf designs to reduce bottlenecks. So these designs eliminate single point of failure and improve performance. And just understanding data center topology is essential for cloud and enterprise networking. Now, what are the key takeaways? The key takeaways, to summarize this section, I'm sorry, I just closed it by mistake. I was trying to move to the next slide. Now, to summarize this section, network exists to enable communication and resource sharing, and then devices in the network have specific roles and responsibilities, and the network designs depends on the size, on the purpose and the environment. And strong fundamentals just makes troubleshooting easier and more logical. And then if you understand these concepts well, everything else in networking will start to make sense. So in the next lesson, we'll explore the OSI model. This model explains how data moves from one device to another. And then once you understand the OSI model, troubleshooting becomes structured instead of confusing. So this is where the networking